the first. The second was far better utilization of heat. Now, one of the things that has happened in the past 8, 10, 15, 20 years is a secular increase in the electrical energy efficiency in all the equipment and in all the installations that are there. But what we are seeing now is the need for, in a sense, heat efficiency as well as of the availability of equipment for heat efficiency. So across a lot of interventions, we are looking at waste heat recovery devices of various sorts. There are the standard waste heat recovery devices where waste heat in industry is captured and then converted into either steam or electricity. And even if there's a small amount, it adds to the overall efficiency. So the only point I'd like to leave you with here is that operating costs have suddenly become, not suddenly, have become more important, are becoming increasingly more important, and the COVID-19 economic lockdown has brought a far greater emphasis on operating costs than there even was before the lockdown. Now think of it. The economic recovery packages that have been made available provide credit for SMEs, for example. Therefore, first costs is something that you can take care of. A SME will buy energy efficient motors, for example. I know I'm giving too simplistic an answer. But what is now important for them is to be competitive in the Indian market and in the global market, that their operational costs are managed. And to this distinguished lecture series, I also want to welcome and say hello to all the participants. It's such a pleasure to be with all of you again. Cost is either labor when energy. Venkat had asked me first to deliver this lecture, having been handed, the one which is being looked at these days is heat efficiency. And therefore, whether we look at the pulp and paper industry or we look even at homes, we in the city of Delhi, you need heating maybe for 2 months or 3 months in a year at the most. Most of us, for those 2 or 3 months, thought it didn't matter very much as far as electricity bills are concerned. We used radiators, which used resistance heating to provide heat. What you are now seeing, and this year has been very, very surprising, we have seen air conditioners with built-in heating just selling off the shelf. We can't get it. I wanted to buy one, and I was told, there is no availability. Why? Because with a air conditioner, you're using a heat pump. And the efficiency of heating essentially falls to the electricity requirement falls to a third of what it would have been. Consequently, in the strangest of places, these kinds of interventions in heat recovery are beginning to occur. Therefore, in the years to come, and I will take this up at the end, in the years to come, one of the things that we are seeing is a need for a constant decline in reduction in energy efficiency, which also means a decline in the energy prices that we pay. This is true no matter where your energy is coming from, whether the energy is fossil fuel based energy or whether the energy is coming from. In fact, and now I'd like to move to my third point on climate change. In fact, what I would argue is that as we look to the future, more and more of the demands for energy efficiency will be driven by climate change. Now, what is occurring is that we are seeing a reduction in the prices of renewable electricity. Solar electricity today is the cheapest electricity available in India anywhere, but only when the sun is shining. At night, it's coal-based electricity which is cheaper, but probably for 2 or 3 more years. Why do I say 2 or 3 more years? Because the most recent tenders that the Solar Energy Corporation of India has brought out has come up with prices for round-the-clock renewable electricity, which is renewables plus a storage, batteries, which is price competitive with coal-based electricity. Actually, it's a little bit cheaper. In other words, in 2 or 3 years, we might get round-the-clock electricity from renewables, which is cheaper than that from coal. Yes, it will be cheaper, but it doesn't mean that it is zero cost. And once we have gotten used to this issue of productivity, of competing on the basis of lowering our costs, the venture to reduce costs will continue irrespective of the shift to renewables. Because when we get renewables, everybody will get the same benefit. Yes, there will be a price drop, but it will be a price drop for everyone. So, if we want to use renewable energy, the challenge then for competitive reasons will be how do I reduce the amount of renewable electricity? So at the same time, I am having a double benefit. I'm getting a benefit myself. I'm also reducing the amount of carbon dioxide that is going into the atmosphere. So I look at energy efficiency as the first step in the move towards decarbonization. Energy efficiency, followed by decarbonization of electricity, which is renewables, followed by the electrification of industry and transport using renewables. And the fourth is for high temperature and long distance transport using probably hydrogen, again, generated from water using renewable electricity. To me, these are the 4 steps that move us towards a zero carbon economy. As far as energy efficiency is concerned, it is important that the equipment that is used is energy efficient. So, for example, if we are looking to a future of renewable electricity or electricity in transport, batteries are very important. Batteries will need to be energy efficient, they will need to be cost effective. And therefore, energy efficient batteries is a here and now problem. Once you get the round the clock renewable electricity at competitive prices, the next challenge will be how do I make it cheaper? And cheaper batteries, energy efficient batteries will be the game that people will then invest in. The second area which I expect to grow is cooling and cold storages. Air conditioning I talked about the challenge of high demands versus relatively constant energy use. This is good, but what it tells us is that in order to get this air conditioning, even that peak load will need to be managed. Because if the peak load is going to be met by renewables, which are needed only for a few thousand hours in a year, then you have a problem. Because we'll have to put a lot of renewable PV load and use it for a very short time, which means that electricity will be much more expensive. That would completely go against the longer term logic of reducing costs. I also mentioned cold storages. In this country, 2/3 of the cold storages that occur today are around towns. They're not in rural areas. Why? You need them in rural areas, so you don't need them around towns. The reason is the poor electricity supply. Cold storages need reliable electricity, and if they don't get reliable electricity from the grid, they generate it from diesel generators, which is very expensive. And that is why there's a limitation in the number of cold storages in rural areas. With reliable electricity occurring, but more importantly, with renewable electricity occurring, cold storages will grow. Now, cold storages is something, if they're getting renewable electricity, then you've got the renewables on one side, but on the other side, if you're getting electricity from renewables, you need to make sure that the heat loss from these cold storages is as low as possible. So energy efficient cold storages, again, become extremely important in the years to come. So whether it is a matter of design, whether it is a matter of operation, in both those areas, we will have to focus on how we build and design cold storage. The third area, which I think is going to become very important, and I alluded to it when I said the fourth step in decarbonization is that industry and long distance transport uses hydrogen, which is made from water using renewable electricity. Well, if it is made from water, it needs electrolyzers. Today's electrolyzers are 85 to 92% efficiency. They will have to be much more efficient for the hydrogen that is made from electrolyzers to be cost effective as compared to the hydrogen that we get today from natural gas reformation. Electrolyzer technology, and particularly energy efficiency in electrolyzer technology, takes into account a host of issues. It takes into account chemical engineering issues, but also materials issues, electricity conduction issues. In other words, this is at the heart of energy efficiency engineering and technology. Another area which I think is extremely important is steel made from zero carbon. When we make steel today in blast furnaces, we use coke as the reducing agent, and CO2 is therefore a natural byproduct. But if we want to make zero carbon hydrogen, what do we use? The only answer that seems to emerge is that we use hydrogen. We use hydrogen as a reduction agent to convert the iron ore into steel. And of course, the hydrogen that we get is from the electrolysis of water using renewable. Is it possible? Is it cost effective? Possible, yes. There's one plant which is being built in Sweden by a company called Hybrid, HYBRIT, which is using this technology and showcasing that it can actually work. Cost effective, it is not. But then, if the decarbonization becomes very, very important, it becomes a policy issue, then this becomes the way to the future towards producing hydrogen, which does not generate, towards producing steel, which did not generate any CO2. This clearly is a futuristic technology, but I thought I would put it on the table because the thermodynamics of it, the efficiency, the cascades through it have not yet been studied. And I think this is at the stage where that preliminary material energy balances need to be applied. The last climate-related efficiency issue that I wanted to focus on was aviation fuels. The aviation fuels we use today are all fossil. But the agreement that the International Civil Aviation Organization has already entered in, which the Indian airlines have already entered in, called CORSIA, looks at a stabilization of the CO2 produced from use. And even if the number of aviation miles goes up, the emissions of CO2 have to stay constant and then decline. And we are not looking at very far. We are looking at, I think, from 24, we will be in a pilot phase. From 28, we have to make it constant. And 2028, which is not that far away. How do we do this? There are talks of electric aeroplanes. I would, however, put my money on biofuels. Biofuels can be used for many things, but in all of those applications, there are options that are there. But in the aviation sector, there really are no options, and I expect that we will see that the vast amount of biofuels that we have will go towards aviation. However, this would mean that the aviation engines, need to be reconfigured. They need to be reconfigured to work with the biofuel, with its properties, with the temperature at which it will, its volatility is different from that of aviation fuel, its viscosity is different, and therefore the engines would need to be redesigned to work with biofuels. Recently, SpiceJet flew a plane from Dehradun to Delhi with one engine working on biofuels. So technically it can. I mean, this is very much like the early cars in which if petrol was not available, you could put a range of other liquid fuels, benzene and so on, and it would run on it and the engines would run. It's very much in the same thing that the engine runs. But does it run optimally? Does it run at the kinds of efficiencies that we are used to? No, it doesn't. And consequently, configuring those engines to be used with biofuels becomes an. So this was the third point that I wanted to make, that there will be a number of energy efficiency issues that will arise as we move towards a low carbon. Let me finally speak about innovation. As we look to the future, we look at a huge number of applications where we will see new materials, new thermodynamic cycles, and in fact, new raw material combinations that we will need. We were talking, for example, of steel and using hydrogen. Now, the kind of iron ore that we find in India is very different from the kind of iron ore that we find in Sweden. And therefore, the technology, even if Hybrid develops a technology that is great, will need to be at least tweaked, but I would say re-engineered for use in India. Similarly, if we are looking at hydrogen, given the shortage of water, I expect that there would be a huge premium on gathering the water back and so that it is again available for splitting into hydrogen. Which means that the kinds of electrolyzer technologies that we will have will probably be those which build in this recycling as well, because the water that comes in would need to be distilled for it to come back here. And therefore, we are looking at technologies which are going to be somewhat different than the technologies that are developed globally. We know that already. We know, for example, that the air conditioners that are developed in India today are no longer the same as are used the world over. And this is because we have taken out all the efficiencies that we could using global practices. Now it matters how you tune it so that the interior and exterior temperatures are matched. The Indian, the ICR, the Indian Seasonal Energy Efficiency Ratio, is now what governs efficiency of air conditioners. And this means that it has to be configured so that it catches the optimal efficiency at a range of temperatures that occurs in India.